Okay, today before we move on to our third transformation, I thought we'd take a minute, pretend we're in the classroom, and do a couple of smart problems. Please note that this notes page is connected to Classroom, and this would be the first slide. Of course, just beware the answers would be the next slide, so you might want to fold it over when you're working on these, or if you have a piece of graph paper, you can do it there as well. We're going to take parallelogram, which is a four-sided figure where opposite sides are parallel. It's not necessarily a rectangle or a square because the angles might not be 90 degrees. We'll see on this one. 4 points. This is our pre-image, and we're going to reflect it over the y-axis. Notice I'm using my reading strategy and circling those. You could plot those 4 points, use the axis of reflection, and move them in the opposite direction. Or you could simply go from this coordinate to its reflected coordinate, talking about the technique that we used in the last video. That's kind of the way a video game or an animated movie would do it. The second 2 problems, you're going to just say which axis did the point reflect over. So you started with this point and it moved here. Which axis did it go over? And then third one here is the best of the bunch, and then it does both a reflection and a translation. So you're going to take this pre-image triangle, you're going to reflect it over the x-axis, and then take that new triangle and translate it 4 units to the right and 3 units down. This is much more like what we would expect to see, tiny little mini step of what we would expect to see in a video game or something like that. I ask you to pause the video. Please do these 4 problems, and we'll come back and see how you did. I'm going to move right over to the answer key here. So if you had plotted the H, I, J, K, it would be the blue one. So just remember, if we're plotting -1, 3, you would start at the origin. The -1 in that first spot would be in the x direction, and since it's negative, you'd go to the left 1. And the +3 in the y direction would mean you would have gone up 3. You would have plotted the 4 points, and that's what I mean by parallelogram. And if you used your figure here to reflect over the y, since h is 1 to the left, the new h prime, would be 1 to the right. I is 1 to the left, the new I prime would be 1 to the right. And then weirdly enough, since k is already to the right, k prime would actually go to the left. So instead of being 2 to the right, it would be 2 to the left. And that's what I mean that it overlaps on itself. It almost, to me, looks 3-dimensional. And then you could have come over here and just written the coordinates of h prime, I prime, j prime, k prime off the graph paper. The other way to do it is to remember that when you reflect over the y-axis, the y-coordinate is going to stay the same, and the x-coordinate will change its sign. So the h prime kept the 3 as the y, but became a +1. And if you'll notice, all 4 of the coordinates have the same y coordinate, but the x coordinates change sign. So whenever you're reflecting, whichever axis you're reflecting over, the y coordinate in this case would stay the same. If you had been reflecting over the x would have stayed the same. Having said that, if you look at number 18, the x stayed the same, so it's the x-axis. And over here, the y stayed the same, so it's the y-axis. Down here, we're going to take this guy and reflect it. So, if we reflect it, I wrote the original coordinates down here from the image. And then notice when we reflect it over the x's stayed the same, and the y's changed sign. And you can kind of see up here that the original s was 1 below the axis of reflection, and s prime would be 1 above. Now, once you have this new red triangle that's been reflected, you're going to translate it 4 units to the right and 3 units down. So that t, if you count, went 4 over and 3 down and became t prime. The other way to do it is to use the translation notation. To the right would be taking your x-coordinate +4, and down would be taking your y-coordinate -3. So if you just come down here and take -4 + 4, you get 0, and 3 - 3 gives you 0. -3 + 4 gives you 1, and 1 - 3 gives you -2. And I'm just putting the x and the y coordinates in and doing this math, and you'll see this is where it moved. So, all three of these triangles are the same shape and the same size. They're all congruent, but they're just being either flipped or slid along the coordinate plane. Now today we're going to add the third, which is a rotation, which is going to be a spin. So we're going to be doing some cartwheels today. And we're going to start by rotating around a vertex. One of the corner points of the shape will basically have a pin in it, and we're going to rotate around it. There are three things you need to know for rotations. I want all of you basketball players out there to remember that you're basically creating a pivot foot. So you're going to stick a pin in the corner, and you can only move in two directions. On an analog traditional clock, as you see, I'm going around here with the second hand. That is called clockwise. If I was to go the other direction than the second hand, that's called counterclockwise. So we need to know which direction are you going to turn, and there's only two possibilities. How far? There's all kinds of degrees and how far you could go, but we are only this year going to look at four possibilities. We're going to look at 90 degrees, which would be a quarter turn. We're going to look at 180 degrees, would be a halfway around, half turn. 270 would be 3/4 of the way around, and of course 360 would bring us right back to where we started. The third thing that we need to know is, what are you rotating around? And today we're going to talk about a corner point, a vertex. And again, it's the kind of the idea of a pivot foot in basketball. Okay, so a rotation is a transformation in which the figure is rotated or turned. And the center of rotation will be a fixed point. And today, again, remember that it will be one of the corner points of the shape, which is called the vertex. So as we start example one here, and let me just fix that little, so you can't read it. There we go. We're going to take the triangle, which happens to be the blue triangle here, LMN. The vertices were given here, the coordinates. They were plotted. And now we're going to take that triangle and we're going to turn it. We're going to rotate it. Remember, we're looking for three things, and I've circled them. What direction? Counterclockwise. How many degrees? 180. And around which of the three corner points? And it will be corner or vertex L. I put a little note here that sometimes a small scrap of paper, if you cut out a little triangle and kind of put it up to the screen or on your paper and rotate it, it'll help you kind of see what's going on. I'm actually going to turn on a rotation tool here to show you how to do this. So I'm going to rotate that blue triangle. Now, just to show you, that would be clockwise. That would be going with the second hand. This would be counterclockwise. And I'm going to go 180 degrees, which is a half turn. Now, if I were to stop here, that would be 90 degrees. And if I keep going another 90 degrees all the way in the opposite direction, there would be the 180 degrees counterclockwise. And notice I stuck the pin in L. If I'd stuck the pin in M, the triangle would have been rotating up around M. So you kind of stick a pin that L doesn't move. The triangle is going to move either towards the left, which is called counterclockwise, or to the right, which is clockwise. And then it's going to stop either a quarter, a half, 3/4, or spin all the way around would be a full rotation. Yes, you can rotate 12 degrees, but in this course, we're only going to do 90, 180, 270, and of course 360 would put you right back where you are. Now I'm just going to set this back so we can see the letters better, and you'll see here is they're showing you the 180 right there around L. And here's where the new coordinates are, and now I read off the graph paper the coordinates, and you'll see down here that L prime is now at 5, 4 right there. Well, it was before. It didn't move. It's the same. The other 2 points, though, did move. The M is now at 5, 1, where it used to be at 5, 7. And the N prime is at 2, 1, where it used to be at 8, 7. And that is called a rotation. You're going to notice I crossed out. We're not going to be using protractors to do this. I've never done it that way. Okay. Now let's take a look at another example. And let me just move him over here. Okay, so, and this got it. You're going to try to do one yourself. So the first thing we need to do is to plot these 4 vertices, -7, 4, -7, 1, so forth, and you'll get a 4-sided shape. Now notice as I read it, it's supposed to represent his bed. You'll notice it's a rectangle. And then you're going to rotate it clockwise, 90 degrees, a quarter turn, and you're going to pin. You're going to not have C move. So either, like I said, you either use a piece of graph paper, or if you printed the notes page ahead of time, you can try this one yourself. So pause the video, and in a second we'll come back and see how we're doing. Okay, so when we come here, you're going to notice that I first started by plotting the 4 points, and now I'm going to stick a pin in vertex C. So C is not going to move, and you're going to see it when I turn on my rotation. That's the corner point that's not going to move. We're going clockwise. That's with the second hand. That will be sort of sweeping to the right, and we're going to do a quarter turn. Now when I click on here, I can now rotate this. Now remember, clockwise will be in this direction, and B, remember, was to the left of C. If we go a quarter turn, B should be directly above C, right? And that's how that would look. Let me just show you on the next slide. It kind of gives it both of those there. Okay, so there's where we just saw it. And now if I wanted to get what are the new coordinates, I just read them off the graph paper. So B would be -2, 1, 2, 3, 4, 5, 6. A would be 1, 6. D would be 1, 1, and C would have stayed the same. And that is how we rotate around a vertex. So I have just a couple more here that we can try together. And again, if you want to stop and try them, or you can continue as we talk them through. So I've got triangle CAT. I'm going to pin T. I'm going to put a pin in T so it doesn't move, and you're going to see me do that by putting the rotation tool. I'm going to go counterclockwise, which is against the second hand, so sweeping to the left, and I'm going to do a quarter turn. So I'm going to go counterclockwise in this direction. That's against the second hand, and a quarter turn. If A was straight above T, it's going to be to the left the T, and you will see the right angle form there, right? You'll see that right angle form. Show you. See here, you can see both of them. So once you've rotated counterclockwise, and it's just asking for C, you can see that it would be -8, 8 to the left and 1 down. And right here, see how I'm tracing that 90-degree angle that's swept to the left in the counterclockwise direction. Okay, this time we're going to still go counterclockwise. We're still going to go around T, but we're not going to go a quarter turn. We're actually going to go 3/4 of the way around. So we're going to sweep 390 degrees, basically, okay? So I'm just going to show you, sometimes you can just pick a line segment, and you can just rotate a line segment to see how one thing, so if you look how point A is going to move there, you can just kind of move it, and we're going counterclockwise. If I was to stop right there, that would be the 90 degrees. But I got to keep going, still pivoting, still turning. If I stopped right there, that would be the 180. And if I come another quarter of the turn, which would put it out to the right, that's where 270 would be. So you can kind of see how I swept. So I'm going to, again, if you don't mind, just show you here. See if I can get this one to rotate. It might not do it here. Yeah. So I'm going to rotate the whole triangle this time. So that would have been 90 counterclockwise. That would be the 180. And there's the 270. Now, I don't know if you've noticed something, but 270 degrees counterclockwise is actually the same thing as 90 clockwise. So if you're going to go 3/4 of the way around in the counterclockwise direction, you could have just gone 1/4 in the other way. So a 90 degrees clockwise rotation around T is the exact same thing as a 270 counterclockwise. So you're going 3/4 one way. The shorter way would have been to go 1/4 the other way. Where was A prime? it would end it at 2, 2, which would be right there, which I'm pointing to. How about one more? So we're going to take triangle cat here. We're going to rotate it this time around A. So I'm going to put my pivot point there. You could imagine sticking your pencil in there. A is not going to move. We're going to go clockwise with the clock in 180 degrees, which is a half turn. So again, I'm going to go with the clock. So I'm turning it this way, right? With the clock. If I was to stop there, that would be 90. I've got to keep going. Another quarter turn around. And what you're going to notice with 180 degrees is that it sends everybody in the complete opposite direction, except for the point A. So the original C was 3 to the left. The new C will be 3 to the right. The original T, notice, was 5 down. The new T will be 5 up. So 180 degrees sends everybody in the opposite direction except for your pivot point. Oh, by the way, 180 degrees, whether you go clockwise or counterclockwise, you're going to land in the same spot. When you take a half turn, you will end up in the same spot whether you turn clockwise or counterclockwise. So where did C prime sort of ended up? He's out here at the point 7, 4. So those are the start of rotations. They take a little bit more doing around the vertex because there isn't a formula that I can give you. You have to understand the angles. And oh, by the way, that's why we reviewed angles before we got here, just to get comfortable with that idea. So anyway, today we're just learning the third rigid transformation, and it is rotation, and we're only doing around a vertex. Every single case today, your image should be congruent to your pre-image. So if you look at these two triangles, they are the same shape and the same size. So when you rotate a shape, it doesn't get bigger, it doesn't get smaller, it doesn't change dimensions in any way. So we're doing some rotations. Tomorrow you'll get a chance to do a little bit of practicing. Then we'll talk about rotating around the origin. I hope you guys all have a fantastic day.